So let's get started. I'll go over a couple of things. So for those who chose the denominators is set that equals to 0, that is correct. We're going to take the denominator, which is x plus 2 equal to 0. We're not going to test out, if you're going to find the x values that make the function discontinuous, we always look at the denominator, not numerator. To solve for this one is just a linear function, so I'm going to minus 2. So x is negative 2. So the answer for part A is negative 2. Then I said some of you chose the numerator, which you factor it out, which is fine. You will factor it out, but that when you factor out the numerator, that is for you to help, that's to help you to figure out the type of discontinuity. So to identify the x values that make the function discontinue, you do the denominator, okay? Then when you figure out the type of discontinuity, then we're going to look at both. So on the numerator, we know it's a special function, so it's x minus 2, x plus 2. Denominator is x plus 2, right? So look at the one that I'm going to focus on is this one, this function. If I can cancel it out, because that's a common term, what type of discontinuity is this? There's two types that we're going to look at, removable and non-removable. So if I can cancel out the factor, it's removable because I can cancel it out. Removable, thank you, Elena. Removable means I can cancel that out. I can get rid of it. That's why it's removable. So it's removable. The reason is because I can cancel it out. All right. So this is what I'm looking at. That is the answer. I have about half of you got it. Some of you forgot. It's been a couple of days. It's over the weekend, and I haven't seen you yesterday. So it's been like 3 days. You forgot. That's okay. Make sure you have that somewhere in your notes, right? So when you take the summative, when you do the work, when you practice, you can always go back. It's much easier if you have right in front of you instead of go through the folder. All of this is in your Schoology folder, in the notes folder. I recorded this, and what you can do is you can go back and look at the video that I shared with you. When is this non-removable? It is non-removable. For example, I'm going to come up with a new example. So let's say if I have x plus 1, and up here I have x minus 1, x plus 2. If I look at this one, this is the function that I'm looking at. I'm looking at the denominator, x plus 1, right? That is the one that I'm going to focus on. So if I solve it, it's going to be x negative 1. Now ask myself, can I cross out this x plus 1? Do I have a common factor for me to cancel it out? So on the top is x minus 1, on the bottom is plus 1. So it's not common factor. I cannot cancel it out. If I cannot cancel it out, what you can say is that it's not continuous at negative 1, and it's non-removable because I cannot cancel out the factor on the denominator. Okay? The factor on the denominator, that's the one that you focus. Can you cancel it out? If yes, it's removable. If you cannot cancel it out, then no, it's not. It's non-removable. Okay? Hopefully that helped. So, other question for me in this one. All right, so we also look at piecewise functions, and one of you asked a question last time was like, do we need to figure out, is this removable or non-removable for piecewise function? We totally could do that, but like I said, we're not going to focus on that one. We're just going to talk about, we're going to do a quick review for piecewise function. I will introduce with you, I will tell you it's removable and non-removable. But right now, I'm not going to ask you to spend too much time on it. It's okay if you remember, or if you don't, that is fine. But I just want you to determine one thing is when you run into piecewise function, we want to figure out if is this continuous or not continuous at 3. That's what we're going to focus at, okay? So let's do a quick review. Who remember the first steps? You have to do 3 things when you run into piecewise function. Anyone remember? What will you do to determine continuity for piecewise function? Victoria, there's a link for you in the chat if you those 3 steps, yes. So what is my first step? What do I do? Plug it in, okay? So step number 1, I need to figure out if f of c is defined. So good. So when you say plug it in, I'm glad that Aisha told me we should plug in the first one because that is the one with the equal sign, right? Because we want to figure out f of c. So we want to know f of 3. What is f of 3? Is this defined? If it's not defined, then I can just stop. I don't have to do anything else. So 3 plus 2 over 2, that would give me 5 over 2. So it is defined, so that's fine, right? Then I will go to step 2. What should be step 2? If you remember step 2. What do I have to test out? Step number 1, I find f of 3. Okay, Jessica, thank you. Victoria, yes, that's correct. I need to find the limit. So to find the limit, I have to test for both. So for the first one, which is 5 over 2, this is the left limit. Then I will do for the right limit, which is 12 minus 2 times 3 over 3. 12 minus 6 over 3. So 6 over 3 give me 2. So look at this problem. I'm looking at the limit. The left limit is 5 over 2. The right limit is 2. Do I need to continue to step 3, or I can draw a conclusion here? I can stop here, right? Because if one of the steps fail, I don't have to do. So there is no limit, so you can say no limit. If there's no limit, is the function continuous or not at 3? It's not continuous, so it's not continuous at x equals 3. So what you do is that you don't have to tell me the reasons if you show me the steps. If you show me step by steps, then at the end you don't have to say it's not continuous because there's no limit. I look at your work and I know there's no limit, and then you can say therefore f of x is not continuous. That's fine. The last x is slipped. Some of you, so keep in mind for practice, even though it looked like the test, I allow you to resubmit your work. So the higher score will be the one that I will keep. I will record that one. So if you need to go back to redo your exercise slip from last class or practice, do so, and then let me know. I'll go back, regrade your work, and keep the highest score, okay? So this function is not continuous at what I'm trying to say, at 3, that's what, okay? So that is the 2 things that we covered for last class. Today we're going to do something a little bit more complicated than what we've been doing, is that when you have the function, they're not going to tell you. You have to figure out what values would make the function continuous. So they gave you something, we're going to solve the equation. What missing is we don't know. We have to figure out what values will make the function continuous. We just kind of go backward, okay? So we have this piecewise function. We're trying to figure out if it's continuous or not at 3. Now, it's at 3, but we need to figure out what values that we have to use for one of the function to make it continuous. So we go backward, right? So make sure you have paper. We are going to ready to take notes. Make sure you join Pear Deck. I'm going to use Pear Deck to take attendance. So I have 17 of you and only 14 of you join Pear Deck. If you have not joined PearDeck, I'm going to share the link again if you came in late and you have not had a chance to join. I will go back and look at the roster and check attendance from there. Okay, so make sure you join. Okay, so this is the one that we're going to focus on today. We will have two Khan Academy for you to practice. One is this new topic that we are about to go over, and then the other one is to figure out if the function is continuous or not on the piecewise function. I think that's the one that half of you still struggle, so we need more practice. It's in Khan Academy, so if you didn't get a good grade, you can always go back and redo, okay? So like I said, for this lesson, for today, we're going to focus on, we're going to find the values that make the function continuous. So we're going backwards. We need to figure what values make it continuous, right? So a couple of things. We know that the function is continuous if f of c, there's three criteria. F of c is defined. Okay, then we figure out the second one is there is a limit. X of c, f of x there is a limit. Okay, then step 3 mean f of c is equal to the limit, and that they must have the same values. So in order for the function to be continuous, it's important to access the limit there is a limit. So to do for this one, I'm going to clear this one so we have space. What you need to do to figure out the a value. So notice this function, you have a, which I don't know. Okay, so I have to do step 1, which means I will plug in the 3 for the x values. I know 3 is x values. So I have to do that first, okay? So I have a instead of x. So I'm trying to solve in that missing. So I know the x value is 3 because that's f of 3. So 3a plus 1 is my first function. I plug it in. Then I will set that equal to my second function, which I also replace the x with 3. So it's gonna be 3 squared a minus 1. So I set them equal. So I'm doing two things. Step number 1, I'm replace the x with this value, which is in this case 3. Step 2, I set both equations equal with each other because I want to know, because I know that if the function is continuous, there must be a limit. If there is a limit, that means the two equations can be equal with each other. That's why I set them equal. So I know it's going to be confusing at first, but right now trying to follow the steps, and then hopefully that makes more sense and later when we finish the problem, okay? So step number 1, replace x values. Step 2, set those two equations equal with each other. So this is step 2. I set them equal with each other. And then step 3, I'm going to solve for a. So I have these two equations. We can just solve for a. We know how to solve equations, so we can combine like terms. Plus 1 on both sides. So 3a plus 2 equal 9a minus 3a. 2 equal 9 minus 3a. That would give me 6a divided by 6. A value is 1 over 3. So the values, the a values that make the function continuous is 1 over 3. The next class, when I see you, we're going to go back and rewrite the function in the proper way. But for today, we're just going to focus on solving for that a values that make the function continuous. So questions for me. So we're going backward. That's what we're trying to do. Okay, still here. Questions? Isla, there's a link for you to join Paired Act, okay? So like I said, we're going backward. So let's move on to the next one. Let's do another one. Hopefully that would make more sense. Okay, so we will figure out, we want to solve for this values A right here. We want to know what that value is so that the function going to be continuous at 2. That's what we're trying to do. So anyone remember, I know we just briefly talked about it. Who remember the first steps? Step number 1, what should I do? Plug in 2, right? So this is the x values. I plug it in, so it's going to be x squared for the first one. And then I would set that equal. I'm going to replace the x's at step 1. I'm going to replace the x with 2. I'm doing that for both equations. Okay, so whenever I have x values, I replace that with 2. And then step 2, I'm just set them equal, which I can do step 1 and 2 all together at once. So I can solve that. Okay. So I set that equal with each other. I forgot one thing. I should replace this with 2, right? Otherwise, I wouldn't know what to do. Okay. So I replace the x with 2. So now I have 4 equal a minus 2. Solve this equation. A is 6. So the a values that you want to solve for, which is 6. So for this function, in order for this function to be continuous, a has to be 6. So that is what you should see. Questions? This is nice and easy. The function is kind of nice for us to solve, but we're going to probably, sometime we're going to run into equation where you have to factor it out. So that's just another example that we looked at. So like for this one, step number 1, I'm just going to repeat the steps. Step number 1, replace the x values. Step number 2, set the two equations equal with each other. Step 3, solve for a. The one that we have to rewrite, that's the one we're going to do more practice with that later for next class. But for today, if you can get to here, that's where you can stop for the day. Okay. All right, if you just joined the class, I have a few of you just joined. Make sure you join Paired Act. I'm going to take attendance from Paired Act, so do so. All of these functions, we're going to find the number, the a values that are going to make it continuous. Yes. We don't know, it may not be continuous, but we want to make sure that it's going to be continuous. So that's why we try to figure out what values would make it continuous. So the a values, if the a value is 6, the function is continuous. If it's something else, it may not. So this value guarantee f of x is continuous at x equal to. So we're trying to figure out what values that are going to guarantee that this function is going to be continuous at 2. If a value is something else, then it's not. Let's say if a is 5, then it's probably there's a jump or there's a hole right there. We're not sure. Okay. All right, let's do another one. I'm trying to see if I can find something that which quadratic function. So let's do, okay, let's do this one. Let's do one more. Okay. All right, so step 1, I'm going to replace the x value. Step 1 and 2, I'm going to do step 1 and 2 together. So step 1 and then step 2. So step 1, I'm replacing the x with 2. So 9 minus 2 squared set that equal with the second equation is going to be 2a. So 9 minus 4, step 3, I'm going to solve it, right? 2a, 5 equal 2a divided by 2. A is 5 over 2. So what this was saying is, when a is 5 over 2, it's guaranteed that f of x, is continuous at x equal 2. Okay. Questions for me? Any question on the steps? So this is step 3 right here that I'm trying to solve it. For the one who have questions, just type in the chat or unmute and let me know. If you don't have questions, I'm going to ask you to try this practice. It is the next slide. Okay. I'm going to turn on the student pace. That way, if you need to go back and copy note from your last slide or anything, you should be able to save it. So I'm going to turn on student's pace. Okay. All right, go ahead and do this one. I'm going to check in to see where you are. And let's see. If you have a question, let me know. Okay.